Mutations. Mutations. A mutation is a permanent change in the DNA sequence of a gene. Mutations in a gene's DNA sequence can alter the amino acid sequence of the protein encoded by the gene.
When a nucleotide in a gene is copied incorrectly during DNA replication, one nucleotide can be substituted with another. This results in the incorrect amino acid sequence, changing the structure of the protein. We can think about the DNA sequence of a gene as a sentence made up entirely of three-letter words. The sun was hot. If you were to split this sentence into individual three-letter words, you would probably read it like this: the sun was hot. If this sentence represents a gene, then each letter corresponds to a nucleotide base, and each word represents a codon. If you shifted the three-letter reading frame, it would result in a sentence which is not understandable, such as this or this. When a nucleotide in a gene is copied incorrectly during DNA replication, a nucleotide can be added or deleted. This results in a reading frame shift and the incorrect amino acid sequence, changing the structure of the protein. A mutation is silent if it has no effect on the protein coded by the gene. The redundancy in the genetic code makes this possible. Each amino acid has more than one possible codon. So, if a substitution occurs, the same amino acid may still be coded. This reduces the possibility of a mutation located in a gene causing a change in the protein.
Mutagens. A mutagen is a physical or chemical agent that can change the DNA of an organism and thus increases the frequency of mutations. Mutagens include ionizing radiation, such as X-rays and gamma rays, ultraviolet waves from sunlight, alkaloid plants, including tobacco, cocoa plant, and poppy plant, sodium azide, a component in many car airbags, and benzene, a solvent used in plastics, synthetic rubber.
Not all mutations are caused by mutagens. Spontaneous mutations occur due to errors involving changes to the chemistry of the DNA, DNA replication, repair, and recombination. This shows a DNA strand slipping out of place during replication, causing a mutation in the DNA once it has been repaired. Are mutations always bad? Not necessarily. Very rarely, a mutation will cause an individual to become stronger than the rest of its population. Sometimes a mutation can give a prokaryote resistance to a new antibiotic or toxin. These would be advantages to the individual, and they may become better able to survive in their environment.